Hi, mathematicians. Let's talk about a class of equations called separable equations. It's a certain class of differential equations, and you're going to learn to love these. They are, in general, the easiest equations to deal with, and you may have come into the class already understanding how to solve these. So in a separable equation, it is possible to get all of your x variables on one side of the equation with your dx and all your y variables on the other side of the equation with your dy. This is a separable equation because I can write it as, and here I'm just going to cross multiply, which would make some of your former math teachers freak out. No, cross multiplying. Yes, I don't think anything's wrong with cross multiplying. There we go. All right, so I just multiplied across, cross multiply. And then at this point, I know that I can just integrate both sides, okay? Just like when we're doing algebra, we can solve an equation by doing the same thing to both sides of the equal sign. So I'm going to go ahead and rewrite this as x minus 5 dx and the integral of y squared dy. And at this point, you should pause the video and go ahead and take a second and solve these. Yes, I'm talking to you. Pause the video, solve them, then come back. Okay, here we go. So what did you get for answers, right? You got 1/2 x squared minus 5x plus c, and I'm going to put a c1 there to indicate that it's the c that belongs to the left-hand side. And over here you got 1/3 y to the third plus c2. Okay, and so if we come back up to our original equation, we might have to ask ourselves, what am I solving for, right? I took this derivative, or excuse me, I took this integral, right? And now I have this big mess here, and I'm not quite sure what to do with it. Well, if we come up here, this says that the derivative of y with respect to x equals this function here. And our job is to find y. So after we separate this and integrate both sides, now at this point, I'm going to go ahead and get y by itself. And so here, let's go ahead and subtract c2 from both sides. So I get 1/2 x squared minus 5x plus c1 minus c2 equals 1/3 y to the third. I'm going to go ahead and multiply both sides by 3. I get 3/2 x squared minus 15x plus 3c1 minus 3c2 equals y to the third, or y cubed. And then the last step is I'm going to go ahead and take the third root of both sides. The third root of something cubed is just itself. So here I have my y alone finally. And then I'm just going to go ahead and write the cubed root of everything underneath. So we're talking about the cubed root of 3/2 x squared minus 15x. Now we have a 3c1 minus 3c2. What are c1 and c2? Just constants, right? So we can go ahead and combine this and just call this c. And that's what you're going to do from now on. Whenever you have two c's combined, here we have a c1 and a c2, you're just going to combine them and call them c, okay? All right, so we found the solution. Y equals the third root of 3 halves x squared minus 15x plus c. What does it mean that we found the solution? It means that if I plug this into here, it should make it true. Meaning, if I take the derivative of this with respect to x and I put it on the left-hand side, it should equal x minus 5 over y squared. I'm not going to do that right now, but I just want to go back and talk about what it means to be the solution. Let's actually move along to Desmos for a second. Nope. Here we go. And if you notice, first, let's go ahead and look at this function down here, okay? This is my dy dx equation. I can't type in dy dx here because Desmos does weird things to it. If you know a way to put in dy dx in there, let me know. But this is the derivative, or this is a function that represents slope, right? This is the slope of some function. And we're given it here, right? This is my dy dx equals x minus 5y squared. This represents the slope or the derivative of some unknown function. What function is that? Well, we went and we separated and integrated both sides, and we got a family of curves of 3 halves x squared minus 15x plus, and then I've put in a whole bunch of different values for c, right? And this is all taken to the 1/3. This is how you put in different values for c, right? And so I'm saying, well, c could be -20, -18, all the way to 20. I'm just asking Desmos to map the family where c are these integers. So if we come in, we see, hopefully you understand that this is just a sample of the field lines, that the field lines actually fill in all this space here. And your solution will depend on your initial conditions. So we found an implicit or a general, let's just call it a general solution. We found a general solution here, okay? And those general solutions are represented by all these purple lines. And again, I hope you understand that they actually exist everywhere. Let's see how these two lines are related. Actually, I'm going to go in just a little bit more. Okay, so here, notice our purple, our slope here, right, is decreasing. These are our family of curves that are solution. Here we have a decreasing slope. And notice this green line that represents the slope is underneath the x-axis, right? It's underneath the x-axis, representing that this slope is negative in this area. Now, where does it switch? Where does the slope switch from being negative to positive? Well, it switches right here, right? At x equals 5. Do you see how this family, any of these purple lines, could be the solution of this green line? Again, the green line represents the slope of all of the purple lines. The purple lines are the family, the general solution with just a random c, right? You got to think about all the values that c could be. And so those are the general solutions, the families of solutions. Here, this shows that we have a negative slope. How do I know that the green line is showing me I have a negative slope? Because the green line represents dy dx, and the green line is underneath the x-axis. That's great because I can see that in the family of solutions, they are all decreasing or do have a negative slope in that region. To the right of x equals 5, the family has a positive slope. And that is exhibited with the green line, which represents dy dx, being above the x-axis. Now, suppose that we're looking for a specific solution. Let's see. Did it throw in my red here? I don't see my graph. It should be a red. Hold on. Let me put my settings. There we go. That's what I wanted us to see. Okay, now I have selected and said, okay, I want to know when the solution, well, actually I put in an IVP. Let's go ahead and go back. And so how did I come up with a solution of 8? I gave an initial condition of the y of 0 equaling 2. Okay, and so I was like, well, if this is the family of solutions, what is the exact solution or unique solution when y is 0 equals 2? Meaning we're going to go through the point 0, 2. Okay, so I went ahead and I plugged that in there. And then, of course, I got 2 equals the cubed root of c. And so then c equals 8. And that is how I then got this red, which is the particular solution for a specific situation with an initial value of 0, 2. Okay, I hope that's helpful.